Kubernetes is about to evict a perfectly healthy running pod, and that is the correct answer to this exam question. Today's CKA task: create a new priority class, patch a deployment to use it, and roll it out on a node that has no room left. The question even warns you that pods from other deployments will be evicted. Most people read that sentence twice. By the end of this video, you will know exactly why it happens and why you should leave the victims alone. Here is the question. Create a new priority class named high priority for user workloads, with a value that is one less than the highest existing user-defined priority class. Then patch the busybox-logger deployment running in the priority namespace to use that new class, and ensure the deployment rolls out successfully. Two warnings come with it. First, it is expected that pods from other deployments in the priority namespace get evicted. Do not modify those other deployments, or you lose points. So the deliverables are one priority class, one patch, one healthy rollout, and the discipline to not touch anything else. Two mechanisms drive this question. First, priority. A priority class is a tiny cluster-scoped object, a name and an integer. When a pod spec names it, the pod is admitted with that integer as its priority. Bigger means more important, and the default is 0. Second, preemption. When the scheduler cannot find a node with room for a pending pod, it looks for nodes where evicting pods of lower priority would make room, evicts them, and schedules the pending pod in the freed space. Now connect that to the task. Patching the deployment's pod template triggers a rolling update. The replacement pods carry the new high priority, and on a full node, the scheduler has to preempt someone to place them. That is why the question can promise evictions in advance. Step 1. What already exists? kubectl get priority class. Read this table the way the question wants you to. The two classes starting with system, node critical and cluster critical, sit around 2 billion. They belong to Kubernetes itself, and you never touch them or count them. The user-defined classes are the other two, low priority at -10. Yes, negative values are legal. And user high priority at 1 million. The highest user-defined value is therefore 1 million, and one less than that is 999,999. That single subtraction is the entire trick of part 1. You do not need YAML for this. kubectl create priority class, high priority, value 999,999, and a description, because the question says it is for user workloads. One line, done. If you prefer the declarative route, the docs page for pod priority and preemption has a copy-paste example, but in an exam, the imperative command is 30 seconds faster. Confirm it. High priority now exists with exactly the value we derived, one less than the highest user-defined class. Before the patch, look at the namespace we are about to disturb. 3 deployments. Busybox-logger, the one we are told to patch, plus QWorker and metrics agent, the other deployments the question warns about. Everything is running. Now print each pod's actual priority. The busybox-logger pods run at 0, the default, because their template names no priority class. The neighbors run at -10 from the low priority class. Keep this picture in mind. The node is nearly out of CPU, and every replacement pod we are about to create outranks everything else here. Part 2. Patch the deployment. The field lives in the pod template. Spec, template, spec. PriorityClassName set to high priority. kubectl patch with a small JSON snippet does it in one command. kubectl edit gets you to the same place if you prefer an editor. The docs show the exact field under the pod spec. The moment this lands, the deployment controller starts a rolling update. It must bring up new pods that carry priority 999,999 on a node that has no space for them. Watch what the scheduler does about that. Here is the moment the question promised. The fresh busybox-logger pod went pending, the scheduler compared priorities, and a low priority neighbor is being terminated to make room. Its replacement sits pending because, at priority -10, it cannot evict anyone. Kubernetes writes this decision down. The events show preempted, naming the victim, evicted by the scheduler on behalf of the higher priority pod. This is not a failure, and there is nothing to fix. The question told you it was expected. Your only job is to let it happen. Part 3. Prove the rollout finished. Rollout status reports the deployment successfully rolled out. Now verify like a grader. Print the priorities again. Both busybox-logger pods now show priority 999,999 with class high priority, and the neighbors still hold their original spec untouched. Notice the namespace healed itself. Once the rolling update retired the old zero priority pods, their CPU freed up, and the evicted neighbor's replacement scheduled on its own. In the exam, it may just as well stay pending, and that is fine too. The question graded the priority class, the patch, and the rollout. The traps in this question are all reading comprehension. Highest user-defined class means you skip everything that starts with system. Counting the 2 billion system classes gives a wildly wrong value. 1 less means -1, so from 1 million you write 999,999. Do not invent a round number. kubectl create priority class is the fastest correct answer, and the priority class name field goes in the pod template, not on the deployment's own spec. When the neighbors get evicted, leave them alone. The question explicitly says modifying other deployments costs points, and preemption is the intended behavior, not an incident. And verify with the pods, not the deployment. Custom columns on spec.priority shows exactly what the grader checks. To recap, we read the existing classes and ignored the system ones, found user high priority at 1 million, and created high priority at 999,999 with a single imperative command. We patched only the busybox-logger pod template with the new priority class name, and the rolling update forced the scheduler's hand on a full node. It preempted a low priority neighbor, recorded a preempted event, and placed the new pods. The rollout completed. Every busybox-logger pod runs at 999,999, and the other deployments were never touched. Priority decides who fits. Preemption decides who leaves. Subscribe for the rest of the CKA series, and the full write-up is on dev.to.